All right, I'm going to go ahead and do problem number one. So I'd like you to try problem number one if you haven't tried it yet, or if you're just plain old stuck. Well, if you haven't tried it yet, try it. If you're just plain old stuck, let's get started. So again, if I got sine of 105 degrees, if I put this on the test for you, I'm not going to tell you to use the half angle, double angle. I'm not going to tell you to use sum or addition. You may use either method, okay? There's a way I can force you to do so, and that would be pick like 22.5 degrees. You have to use half angle and angle for that. So you're going to have to learn how to do this anyways, okay? But if I recognize that 105 degrees is half of 210, then I could write this as the sine of 210 over 2 is equal to the sine of 105, because 210 divided by 2 is 105. And then I go ahead and whip out my half angle identity. My half angle identity is plus or minus the square root of 1 minus cosine of theta over 2. Theta being, in this case, 210 degrees. All right, first thing I'm going to do is deal with this plus or minus. Sine of 105 degrees, that would be the second quadrant. Sine is positive there, so it's just a positive one. Okay, 1 minus cosine of 210 degrees. Cosine of 210 degrees is, if I go over here and do my reference angle thing, this is 180 degrees, right? So the 210 would be just past that another 30 degrees. So cosine of 30 degrees is root 3 over 2. But since it's a third quadrant, it's going to be negative over 2. And so I get the square root of, I've got a common denominator situation, I got a negative, negative, so I'm adding. So this is going to be 2 plus root 3 over 2. And again, all I'm doing is writing 1 over 1, multiplying the bottoms, crossing the tops, all over 2. Okay? Now the next step's always going to be the same. I'm going to flip and multiply, so write that as 2 over 1. I get the square root of 2 plus root 3 over 2 times 1 over 2. All underneath the square root bar. And that's going to give me the square root of 2 plus root 3 over 4. Again, multiplying fractions, multiply straight across. 1 doesn't change anything. 2 times 2 is 4. And then I got a square root of 4 on the bottom, which is nice. And it goes 2 plus root 3 over 2. And I'm done with this problem. Fair enough. All right, so go ahead and do 2 and 3. When you get done with that, try number 4. I will jump on number 4 right. Oh, actually, you know what? I'm going to do number 5. So do 1, 2, 3, and then skip to 5. We'll do 5 together, okay? And then once we're done with 5, then we'll be ready to do the rest of this page. And it'll be fun and entertaining and all that stuff, okay? All right, so I'm going to give you a little time to pause it so you can get through 2, 3, and 5, okay? 2, 3, and 5. Well, you can check your answer by typing in tan of pi over 8, make sure you're in radians. Check to see if it matches what you get when you do when you plug this in your calculator, right? Whenever you get, okay? All right. All right. I'm going to do, actually, you know what? I'm going to do the answer tonight. I'm going to do the answer number 2, and then I'll do number 5 afterwards. So let's do 2. Go ahead and make sure you get 2 done, and then I'll write the answer here. All right, the tan identity is plus or minus the square root of, essentially we're going to write the sine 1 over the cosine 1. Again, it's on the formula sheet this way anyway, so you don't even have to memorize that part. We can do it anyways. So it'd be 1 minus cosine. Oh, first of all, I'm going to realize that tangent of pi over 8 is equal to the same as pi over 4 divided by 2 tangent of that, right? If flip and multiply, I get 1/8. Or you could change this into 22.5 degrees and then get 45 over 2, right? Because this would be equal to tangent of 45 over 2. If you recognize, if you went through and changed this to pi over 8, where 2 pi is 360 degrees, you would get 22.5 degrees. Or if you really care with cat fractions, you get 45 over 2, which would make it really obvious what you should do. And you get to this point right here. Okay? All right, so I've got this set up. So I'm going to use plus or minus the square root of 1 minus cosine of 45 degrees over square root of 1 plus cosine of 45 degrees. I'm using that original angle, not the half. Okay, first thing to do, plus or minus. Tangent in the first quadrant. Tangent of 22.5 degrees has got to be positive because it's the first quadrant. So I'm going to write this as 1 minus root 2 over 2 over 1 plus root 2 over 2. I got 2's in the bottom. I rewrite this as 1 over 1. Multiply the bottoms, cross the tops. At some point, you should get good at that. If you're not getting good at that, come and see me. We'll spend some time adding fractions. It says quality like that. 2 plus root 2 over 2. Okay, flip and multiply. I'm going to get square root of 2 minus root 2 over 2 times, since they're both in square root bars, I can multiply them straight in. So it's 2 over 2 plus root 2. These two canceled out because they're multiplied, and we're multiplied, I can cancel them out. And that gives me the square root of 2 minus root 2 over 2 plus root 2. How do I get rid of a 2 plus root 2 on the bottom? I'm going to multiply top and bottom by 2 minus root 2. Yes, we're going to get to do that in this problem as well. This is going to be fun. I'm going to go ahead and write over here because I need a lot more room. So I've got the square root of, I'm going to FOIL, so I've got 4 minus 2 root 2 minus 2 root 2 minus 2. No, that's plus because it's negative. All over. And on the bottom, I've got 2. I got 4. And then I've got the two middle terms cancel out, minus 2. So this gives me the square root of 6 minus 4 root 2 over 2. I know that the 2 goes into both of these on the top, so that gives me 3 minus 2 root 2's, and that's my answer. Ain't that fun? So we're going to, so that's that. Okay, again, I'm going to do number 5, so go ahead and do 3 and 5. All right, you should have already done 5. If you haven't done 5, try it. There's a glitch here, and I make sure you run into it the hard way before I just give you the answer and you never remember again that it's there. Okay? If you've already tried it, let's do it. Okay, I want to recognize the following. There's something weird going on here. Notice how theta is between pi and 3 pi over 2. What does that mean? Oh, it's in the third quadrant, right? Why do I care about that? It doesn't matter at all. I want to find sine of 2 theta, so I don't really care about that at all. So sine of 2 theta is equal to 2 sine theta cosine theta. So now I'm going to go ahead and do 2 sine. What's sine of theta? Uh-oh. I need to draw it, right? Because I have this information here. So I'm going to go ahead and go, draw it. So I get ready to draw it, and instinctively start to go to the first one and realize, wait a second, this is saying it's between pi and 3 pi over 2. If this is 0, this is pi, this is 2 pi, then this must be 3 pi over 2 down here, so we're drawing this in the third quadrant. And so I look and go, oh, crud, okay, so I can do that. So I'm going to go like this, and I'm going to go down. I'm going to recognize that theta is in here, so it's going to be opposite, which is 1, over adjacent, which is 2. But notice something's wrong here. I noticed that I went down. Down means that's got to be negative. Well, how can it be positive? Well, I also went to the left. So negative divided by negative is positive. Now, I know full well I'm going to need the hypotenuse, so I might as well go ahead and start working on the hypotenuse. That's 1 squared plus negative 2 squared equals c squared. And that's going to give me 1 plus 4 equals c squared, or c equals plus or minus root 5. We agreed the hypotenuse is never going to be positive, or sorry, never be negative, so we don't have to worry about it. So I'm going to use root 5 down there. Here we go. So sine is going to be negative 1 over root 5, and this is negative 2 over root 5, right? Adjacent, opposite over hypotenuse, adjacent over hypotenuse, and therefore I'm going to get negative, negative makes it positive, multiply straight across, I get 4 over 5. Isn't that nice? And then for the second part, I asked find cosine of 2 theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta, right? And so I'm going to go ahead and do that. I'm going to go cosine of theta. Cosine of theta was negative 2 over root 5. I'm going to square that minus, and then I'm do adjacent, which is -1 over root 5 squared, and I get 4/5 minus 1/5, and that's equal to 3/5. Isn't that nice? That's two of them. Okay. And then tangent 2 theta. Well, tangent 2 theta is going to be opposite. It's going to be, the identity for tangent 2 theta is 2 tan theta over 1 minus tan squared theta. So 2, tangent theta is going to be opposite over adjacent, so that's -1 over 2, and then 1 minus -1 over 2 squared. So that's going to, on the top, it's going to give me, multiply straight across, right, this is over 1, I get -2 over 2. And on the bottom, I get 1 minus 1/4. So that becomes 1 over 1 minus 1/4, which is 3/4. I flip and multiply, and I get 4/3. And I recognize that if I do sine over cosine, I would get 4/3. And so everything checks out, and I'm feeling really good about my life and everything else. All right, I won't hassle you for the mark. Go ahead and do 4, 6, and 7, and then try number 8, and I'll catch you here on number 8. If you have not done problem number 8 and you get to this point, you need to stop this video immediately because you're going to run into a glitch. I need you to run into the glitch. I don't want you to go, well, and not be able to see it later, right? And so we are absolutely in need of you doing this problem. If you don't do the problem, you're on your own and you sneak past this point, great. Good for you. I'll see you on the test when I write the same problem in the test. It says here sine 2x and it says x and x. Now I'm going to tell you something right now. As long as it says 2x and these say x's, I'm not going to be able to set these equal to each other, right? Now the purpose of verification is to prove they're equal to each other. So there's 0 chances it's going to work. So you need to change x's into 2x's or 2x's into x's. It is very traditional to change a 2x into an x because we were used to x's right themselves. So I'm going to go ahead and change that out right away. 2 sine x cosine x. That was quick. And then over here I got a plus with a square, so I'm going to have to FOIL this. So I get sine squared x plus sine x cosine x plus cosine squared x. And then I got 1 plus 2 sine x cosine x equals sine squared x plus, oh, I got another sine x cosine x up here. Get this right. Plus 2 sine x cosine x plus cosine squared x. And so I've got this equation there. At this point I should feel it tingles, right? These two here are tingly. And I got 1 plus 2 sine x cosine x. And they match, and I've got, well, that's really good. All right, now, just know that whenever you have a double angle or a half angle, step 1 is going to delete that. Just get it out of there. It's going to be a problem. You can't solve it. You cannot make 2x equal to an x, so it has to go. Since it has to go, that's going to now become our new step 1 for all verifications. If you see a double or half angle, kill it immediately if you can. Okay? You know, sometimes that won't work great for you, but most of the time that is a very good first move. Got it? All right. All right. Hopefully everybody has a good time with this. See you on Wednesday.